This question asks, according to Newton's law of gravity, force between two objects depends on the object's masses and separation according to which correct statement? Remember, the force of gravity is a force between any two masses. Like this one here is mass 1 and this one here is mass 2, separated by a distance. Any two masses in the universe are going to exert an attractive force on each other that we call the gravitational force. Now, that gravitational force is directly related to each of the masses. Directly related to mass 1 and directly related to mass 2. It's a direct relationship, meaning if we increase mass 1, the gravitational force is going to increase. If we increase mass 2, the gravitational force is going to increase. If we decrease either one of them, the gravitational force is going to decrease. Now, that gravitational force is inversely related actually to the distance squared. The larger the distance, the smaller the force. The smaller the distance, the larger the force. But it is really a distance square dependence, which means it's going to change more quickly than a regular inverse relationship. So the gravitational force is going to decrease quite a bit when we increase the distance. It's going to increase quite a bit when we decrease the distance. So in this case, the answers we have, the force is directly proportional to the product of the masses and inversely related to the separation squared. Now, this is the correct answer because it tells me it is inversely related to the separation, which is the distance squared, and it also tells me it is proportional to the product of the masses. So both masses are going to play a role. Now, the second one here is obviously wrong because it says it is directly proportional to the separation. So it's saying if we increase the distance, the force would increase. So that would be wrong. This one here, first, it misses the fact that the separation needs to be squared. But more importantly, it says it is proportional to the total mass. So this one, in this case, it will say the gravitational force is going to exist even if one of the objects does not have a mass. While that's not correct. Both of them have to have a mass for us to have a gravitational force.